Welcome students. Myself Mr. Airav VA. Here we are going to learn the frequency measurement by Lissajous pattern and Z-modulation technique. Objective: to learn the frequency measurement using the Lissajous pattern or Lissajous figure method and Z-modulation technique. Outcome: students will be able to demonstrate the unknown frequency measurement using Lissajous pattern and Z-modulation technique. First, we will learn how to measure unknown frequency by the Lissajous pattern. Lissajous pattern or figure, it is a special characteristics which will appear on the screen of the oscilloscope when you will give two sinusoidal voltages and simultaneously fade to the horizontal and vertical plates through the two channels. These patterns are called as the Lissajous patterns or figures. The shape of the Lissajous patterns or figures depends upon first, amplitudes of the two signals, second, phase relationship between the two signals, and third, the frequency ratio of the two waveforms. Some of the sample Lissajous pattern we may see here through different figures. In the third figure, they have also numbered few points at the horizontal tangent as well as vertical tangent. And below these Lissajous patterns, they have also mentioned the vertical deflecting plates frequencies FV in terms of some multiple of the horizontal deflecting plates frequencies. Now we will see how exactly we have to use the Lissajous pattern for unknown frequency measurement. Very first, the unknown frequency you have to apply to the Y plate. So for this one, you can use channel Y on the front panel of CRO, and to the X channel you have to apply the accurately known calibrated standard frequency, and it should be a variable one, and that you have to apply to the X channel. The internal sweep generator will get disconnected as to observe the Lissajous pattern we have to switch the oscilloscope in the XY mode. After that one, the standard frequency is adjusted till the time it will be equal or multiple or submultiple of the frequency of the unknown source, so that the Lissajous pattern appears to be almost stationary. For example, the figure shows the signal or a sine wave which is applied to the X plates through channel X and having a frequency say F. The sine wave which is applied to the Y plates through channel Y. Assume it is having twice of the frequency applied to the channel X. If you will apply these sine waves simultaneously to channel X and channel Y, and after switching the CRO in XY mode, a Lissajous pattern as shown in this figure will be observed. Then, with the help of a simple equation as the ratio of unknown to known frequency is equal to the number of times the tangent touches to the top or bottom, that is a horizontal tangent, upon number of times the tangent touches to either of the side, means either to the left side or to the right side, that is a vertical tangent. The horizontal tangent shown by here a red thick line and a vertical green thick line, or number of horizontal tangencies you can measure upon number of vertical tangencies. Now, as per the Lissajous pattern, the number of horizontal tangencies are 2, means the tangent touches 2 times to the Lissajous pattern, and that is the horizontal tangent. But the vertical tangent touches to the Lissajous pattern only once, and hence we may write Fy upon Fx is equal to 2 by 1, or Fy is 2 times Fx. In this way, by obtaining the stationary Lissajous pattern, you can easily measure the unknown frequency. But only one limitation is there by this method. The unknown frequency must be either equal to the known or multiple or submultiples to the known frequency. If you are having a Lissajous pattern as shown here, which is having an open end at one side, but that particular Lissajous pattern can also be used for measuring the unknown frequency. And here, whatever open end is there, that tangency you have to consider as a half tangency. So by this one, there is one half tangency and two full tangencies. And for this one, we may write Fy upon Fx is equal to 2 plus half upon 1, because there is only one vertical tangency and 2 and half horizontal tangencies, and thereby you will get the relation that Fy upon Fx is equal to 5 by 2, or Fy is equal to 5 by 2 times the known frequency, that is Fx. In this way, you can easily use the Lissajous pattern for the measurement of unknown frequency. In the second part, we will go for frequency measurement by Z-modulation technique. This is also called as the intensity modulation. The name Z-modulation is by the channel Z is used for the application of the unknown frequency, and the name intensity modulation used because the intensity of the resultant pattern will get modulated. Most of the oscilloscopes are having a connector at the rear panel for the intensity modulation inputs. This is called as the Z-axis input. The input will actually modulate the voltage on the grid of the oscilloscope, and by that one the grid voltage will be driven more negative during the negative half cycle. Because of this one, the intensity will be either dim or it may be completely blank, and we will have a short line, that is a more intensity line, followed by a less intensity line or a gap which will represent one cycle, and each trace of the Lissajous figure will get completed by one cycle of the vertical and horizontal inputs. This technique is easily useful for unknown frequency measurement, and that unknown frequency will be applied to the Z-axis input. For example, consider I have applied the input, that is a sine wave, to both the channels, that is X and Y, and in XY mode I am getting a Lissajous pattern like an ellipse. When I will apply the unknown frequency to the Z input, then I may get the Lissajous pattern as shown in figure 2nd. So if you will observe carefully the difference, the trace is same, but in this one we are getting three portions having more intensity, and remaining three portions are having very less intensity, or they may be completely blank. If you will obtain such Lissajous pattern having certain number of gaps or cuts, and that should be measurable, then you have to apply the equation Fm upon Fp, where Fm is the modulating frequency which we need to apply to the Z channel, and Fp will be the deflecting plate frequency which will get applied to the Y and X channels. You have to remember Fm is the unknown frequency and Fp will be the known frequency. Their ratio will be equal to number of gaps or cuts upon 1. So as per our diagram, Fm upon Fp will be equal to 3 upon 1, or the unknown frequency in terms of the modulating frequency is 3 times to that of my deflecting plate frequency, which is known to me. You may refer the two books. First one by A.K. Sohani, Electrical and Electronics Measurements and Instruments, and the second one by David Bell, Electronic Instrumentation and Measurements. Thank you.